Hi, fifth graders. Miss Brocker here. Today is Wednesday, December 9th. Our learning target today, or actually learning targets, are I can represent fraction values in many ways, including of a whole, of a set, and on a number line. I put a little to-do list in here for you today as well. This can be found on Schoology in the math page, which you've already got to if you open this video. But today is an independent learning day. Please watch this whole lesson video and then do your Wednesday slides and your Google Slides assignment. Work on your study island assignment, and some of you have assignments for the week. Check to make sure your Unit 3 post-assessment on Schoology and your Unit 4 pre-assessment on Study Island are done. And then if you have extra time, you can explore the Unit 4 resource folder where there's a lot of fraction games and extra practice there. If you need help, you can feel free to send me an email. I'll be at my computer for most of the day. Or you can check out the Unit 4 anchor chart slides that are in the math folder. There's a link to them. Okay, one of the first things that you're going to do on your slides today is work on using number lines with fractions. So a number line is just a line that has intervals or is partitioned like we partitioned wholes yesterday. And what it does is it helps us visualize numbers and sometimes show the relationship between numbers and even their size with fractions. So what you see on your screen right now are two number lines. We're going to start with this one over here on the right. And on your first slide today, you're going to see a couple number lines that are already partitioned or already have those intervals in them. And what you're going to do is you are going to figure out how it is partitioned or what fraction is shown on the number line. So even though we don't have any fraction shown, we are going to, here's the hint I'm going to give you. Yesterday we worked on partitioning wholes and drawing lines to break up wholes. So you can use the same thinking with this number line and any of the number lines you come across today. If we start at 0 and we had our whole right here, this is 0, this is 1, and I see we have 1 line, 2 lines, 3 lines. How many pieces are now in our whole? I see 4. Okay. So we have 0/4. 1/4 would be this line. 2/4 is here, or half. 3/4, and then over here 4/4. So what you need to do on your first slide is you need to decide how that number line is partitioned and match it with the fraction name. So if we have 4 pieces, this number line would be partitioned into fourths. Fourths. And you would just use that label. Okay, and this other number line over here, we can do the same thing. Now, if you don't want to draw your whole on there, you don't have to. You can just kind of do some guess and check strategy to figure this out by counting by fractions to get from 0 to 1 whole. So from here, what we're going to look at, we're not going to look at this whole number line because hopefully you notice that we go from 0 to 2. And for us to figure out how this was partitioned, I think it would be more useful to go to look at only this space right here from 0 to 1. And then we can count how many spaces are there. 1, 2, 3. Kind of like we counted 1, 2, 3, 4 here with these lines. Don't count the lines, count the spaces. So we're counting 1, 2, 3, 4 in our one whole. So if I did that same thing here, use a green marker so this stands out. We have 1, 2, 3. So I already know that this is in thirds. 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 And you're not going to label this on your slides, but this is important for the next slide. So we have 0/3 at 0, 1/3 at our first bump, 2/3 at our second bump, and then 1 whole is always going to be a whole fraction, 3 out of 3, 3/3. And again, if you're looking for a strategy that helps you, you can put or imagine what we did yesterday, partitioning a whole fraction bar. And just think, if you put lines, you replace those lines with those little dashes on the number line. Now do you see that that whole looks exactly the same as the number line, and you can easily see thirds. Okay, the second thing you're going to do with number lines today on your practice is you are going to be placing fractions onto a number line. Now, your number lines today on your Google Slides are already partitioned for you. So I have on my slide right now one that is already partitioned, and we're going to actually work on partitioning this other number line on the left, which you can see is just a flat line right now. I see that on all of these fraction values down here, we have a denominator of 9. So what that means is we're going to need to break our number line into ninths. So we're going to have to draw 8 lines. So this can get a little bit tricky, and we'll work on this tomorrow in class as well, but I'm just going to show you how I prefer to do this. And I actually like to think about multiplication when I do this. So I'm going to just start by drawing my 0 ninths, 3 ninths, 6 ninths, and then 9 ninths. Okay, so I'm going to label those real quick. So 9 ninths, 6 ninths, 3 ninths, and 0 ninths. Okay, we haven't put anything on there yet. And now I know I'm going to have 1 ninth and 2 ninths that comes between there, and then 4 ninths and 5 ninths, and 6 ninths, 7 ninths, 8 ninths, 9 ninths. Okay, now I'm not going to label all those because I can just use those kind of benchmarks to help me count them. Now, what we're going to do, and you're going to do this on your practice, you're going to take your fractions and you are going to place them on this number line. So I can already see 6 ninths goes right there. I already have that labeled. And then I kind of like to use a jump strategy for this. So instead of trying to figure out where 8 ninths is right away, I go to one that I can see. So either go backwards from 9 ninths, count one jump backwards, or go up from 6 ninths, 7 ninths, 8 ninths right there. And then lastly, 2 ninths. So you could go backwards from 3 ninths, or you could count 1 ninth, 2 ninths. Okay, so I'm going to kind of circle those so they stand out. Right here, right here, right here. Okay, now this one over here has already been partitioned into fifths. So this one I'm going to do without doing any labeling, but I have 0 fifths, 1 5, 2 5, 3 5, 4 5, 5 5 would be one whole. So I know right away that my 4 5 is going to go one jump below my 5 5. Okay, I know my 1 5 is going to go one jump, placed on that number line, one jump above 0 5. And then I can count either up from there or count back from 4 5 to get to where my 2 5 and 3 5. So I know that this one goes right here. Okay, one of your other learning targets is to represent fractions of a set or of a group of items. So some of you are going to be doing this. Actually, everybody has one of these slides on their Google Practice today where you are going to be finding certain pieces of a whole, and then some kiddos have where you're going to be finding fraction of a whole number, but we will review this tomorrow as well. The first thing we're going to do this one over here actually first. And oh, I changed my mind. Sorry. We're going to do this one over here. And what we're going to do is we're going to find a fraction of the set of objects. So here we have 12 Hatchimals. I hope that you don't make fun of me for saying that weird. And we're going to find 1/3 of them. Okay, so the easiest way to do this is to break your set into that denominator, because we know with the fraction 1/3, 3 tells us how many equal pieces we have in our whole. So if we have the denominator of 3, that means we're going to break our whole, or 12, into 3 equal groups. So it's a little bit harder when they're all kind of mixed up like this. Instead of those stars on the right are all in nice, neat rows. But I know, and hopefully you know this too, that 12 divided by 3, or to make 3 groups out of 12, I'm going to circle 4 of these. And that's it. So 4 of them would be 1/3. So now look at if I circle 4 of these and it looks kind of weird. Do you see how I have 3 equal groups of 4? There's 4 in this group, 4 in this group, 4 in this group. Another way you could think about this is by doing a little bar model or a little fraction bar, and you know that this whole bar represents 12, and we want to find out how many go into 1/3. If you know that this 1/3 is 4, 4, 4, you know 1/3 of 12 is 4. So equals 4. Okay, now that becomes a little bit easier when you have these lined up all nice. So what we're going to do in this one, this is a little bit more complicated. We're going to find out what 2/6 of this set is. So the first thing to do would be to look and see how many are in this set. I'm going to use skip counting or multiplication thinking here because this looks like a multiplication array. I am going to use I'm going to go the long way. So see, we have 2, 4, 6, and we have 3 rows of 6. So what that tells me is we have 18 in all. Now I'm going to look here at my denominator, and I want to try and make 6 groups of 18. And what we're going to do is the same thing we did over here. We broke that whole 12 into 3 equal groups. We're going to break our 18 into 6 equal groups. Okay, so what I see is we have 1, 2, 3, 4, 5, 6. Okay, now what I did is I just used my green marker to break our total 18, our set, into 6 equal groups. And then we are trying to find the fraction 2 6. So how many of them are we going to count? 2. Remember that numerator counts how many we have or how many we are counting. So I'm just going to box in 2 groups of our 1/6. So each one of these counts for 1/6 of 18. We can see that there are 3 stars is equal to 1/6 of 18. So I know over here, if I box in 2 of those 1/6 groups, we have 2/6 of 18. And that is equal to how many stars? Go ahead and count them, or you could do 3 times 2 is equal to 6 stars. Okay, if you were in the blue group, you will see these in your practice today, and we will work on these later this week. But this is the same concept as what we just did, finding fractions of a set, except for you don't have that visual model to help you. So now you are finding fractions of a whole number. So instead of a set of objects, just a whole number. So we have 2 problems here. We're going to start with this one over here on the left. We are going to find out what 1/8 of 24 is. So there's a couple different ways you can think about this, but my favorite is to think, if we break 24 into 8 equal groups, how many is one of those groups going to be worth? Now, a model might be really helpful for you in thinking about this. So you could just draw on your whiteboard a rectangle. This is why we did bar modeling in our last unit, multiplication and division, because that's what this is right here. So if I know that my whole bar right here represents 24, we need to find out what 1/8 of that is. So first what we're going to do is we are going to partition our whole into 8 equal pieces. So I'm going to do that pretty quick here. I'm going to draw black lines. And remember, we want to draw 1 less than our denominator. So I'm going to end up drawing 7 lines. 6, 7. Okay, now those aren't perfect, but what I do know is that each one of these is equal to 1/8. So if I'm trying to find what 1/8 of 24 is, what I can do is divide 24 by 8 and then multiply that number by 1 because we only have one piece. Let me make sure I have 8 here. 2, 4, 6, 8 looks good. So 24 divided by 8 equals 3. Each one of these is 3, 3, 3, 3, 3, 3, 3. 1/8 of 24 is equal to 3. Now think, in case you have a slide like this today, now think, what if we instead wanted 2/8 of 24? What could we do with our bar modeling here? Well, instead of counting just 1 3, we could count 2, which would be equal to 6. Or we could count 3, which would be 3/8 of 24 would be equal to 9. And so on and so forth. So we're going to use that logic over here. We're going to now find 3/10 of 90. So again, you could think that a bar model would be helpful. You could use a number line as well. And you would be breaking this into 10 sections, but drawing 9 lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, remember, when you draw these models, they don't have to be perfect, just enough for us to get some understanding from them. So we know that this whole bar represents 90. 90 is our whole or our set. What we're trying to figure out is how much 3/10 of 90 is. So I know each one of these boxes represents 1/10, 1/10, 1/10. And we need to figure out, to get this answer, how much 1/10 of 90 is. Okay, which AKA means divide. So we're going to do 90 divided by our denominator, which is 10. 90 divided by 10 equals 9. So I know each one of these boxes represents 9, 9, 9, 9, 9, 9, and I could fill those ones in. But if I know that one of them equals 9, how many does 3 of those equal? Because our numerator is 3. We have 3 out of 10. So if I know each one of these is 9, I can do 9 times 3 equals 27. So 3/10 of 90 equals 27.